Welcome to the AI Checkpoints. Before we jump in, just a quick heads up. The content you're about to hear is generated by AI. Today, we're doing a really deep dive into something pretty fascinating, I think. We're looking at how advanced AI systems are being built to tackle complex research, but not just as, a single AI brain. We're talking about coordinated teams of AI. Our main source for this is a great blog post from Anthropic, published back on June 13th, 2025. It's called How We Built Our Multi-Agent Research System. And our mission today is really to unpack the engineering side, the challenges, the lessons they learn, basically how you get AI agents to collaborate effectively on research. So imagine an AI that doesn't just spit back answers, but actively goes out, researches, synthesizes info from all over the web, your own files, maybe by deploying a whole team of specialized AI agents. That's the core idea we're digging into today. Okay, so let's unpack this a bit more. Anthropic's research feature, the one they described, it uses multiple Claude agents. And they're working together using tools, kind of in this loop, exploring complex topics pretty autonomously. It almost sounds like a little AI research department.
It really does.
Yeah.
And the why behind it is, I think, really compelling for research tasks. Research often deals with these really open-ended problems. They're dynamic. Things change as you learn more. And they're very path-dependent, meaning the steps you take depend entirely on what you found in the previous step. You can't just hard-code a path.
Right. You discover something and that sends you off in a new direction.
Exactly. Human researchers pivot all the time. AI needs that same flexibility. A linear, sort of one-shot approach, it just doesn't work for that kind of dynamic exploration.
Yeah.
But multi-agent systems, because they can operate autonomously over many steps, making decisions based on what they're finding, they're actually really well suited for this.
That makes a lot of sense. So it's less about one super smart AI and more about simulating that collaborative human intelligence.
Precisely. There's this analogy to human collective intelligence, right? How societies scale up capabilities through coordination, specialization. Well, groups of AI agents can potentially do something similar, achieve much more than a single agent working alone. It's like artificial collective intelligence.
And Anthropic actually saw some pretty dramatic performance increases with this approach.
Well, absolutely. They mentioned in their internal tests a multi-agent system using their top model, Claude Opus 4, as the lead agent, and then coordinating Claude Sonnet 4 models as subagents.
Yeah.
Those are a bit more efficient for specific tasks. This setup outperformed a single Claude Opus 4 agent by, get this, 90.2% on their internal research evaluation.
Wow, 90%. That's huge. Do they give an example of where that makes a difference?
Yeah, they did. A good one was identifying all the board members for information technology S&P 500 companies. The multi-agent system could break that down, assign parts, and actually get the job done. The single agent, trying to do it all sequentially, it failed. It couldn't complete the task.
Okay, that really highlights the power of breaking down the problem and working in parallel. So connecting this back, you mentioned performance. Is it fair to say these systems work better because they just, spend enough tokens to solve the problem?
That's a really key insight they pulled out, yeah. Their analysis of this evaluation called BrowseComp, which tests how well agents find tricky information online. They found that token usage alone explained about 80% of the variance in performance.
80%? Just from tokens used?
Yeah. It suggests that a big part of solving these hard problems is about allocating enough computational effort, intelligently. And the subagents help here because they work in parallel, each with its own context window. That allows for a kind of compression of insights from huge amounts of data, and it makes the whole process less dependent on one single path. Plus, they noted the newer models like Sonnet 4 are like efficiency multipliers. They get more done per token.
So it's a combination of smarter coordination and just bringing more processing power to bear, but in a distributed way.
Exactly. It's really a shift from thinking about a single AI mind to thinking about an AI team.
Okay, that performance boost is definitely impressive, but how do they actually structure these systems? Let's maybe peek under the hood a bit.
Sure. So the core design pattern they use is what's called an orchestrator worker pattern. Sounds a bit formal, but it's pretty intuitive. You've got a main lead agent, the orchestrator, that coordinates everything, and then it delegates specific tasks out to specialized subagents, the workers who often operate in parallel.
Like a project manager and their team members.
Pretty much, yeah. So when you give it a query, the lead agent first figures out a strategy. Then it spins up these subagents to tackle different parts of that strategy simultaneously. The subagents use tools like web search, gather info, filter it, and report back their findings to the lead agent. Then the lead agent pulls it all together.
And that's quite different from some of the maybe more traditional AI methods people might know, like RAG, retrieval augmented generation.
Definitely. This multi-step search process is dynamic. It adapts as new information comes in. RAG typically is more static. You retrieve a set of documents based on the initial query, and then the AI generates an answer from those documents.
Right, it doesn't usually go back and search again based on the first answer.
Exactly. Anthropic system is much more iterative. They actually map out the whole workflow. It starts with your query, goes to this lead researcher agent. First thing it does is plan the approach, and importantly, saves it to memory. This is key, because these agents can handle huge contexts, like 200,000 tokens, but even that can be exceeded in complex research. This memory helps maintain continuity.
So it doesn't lose track even on really big tasks.
Precisely. Then, the lead researcher creates the specialized subagents. Could be just a few, could be many, each with a specific job. Each subagent goes off, does its web searches, evaluates results, using this idea of interleaved thinking, basically thinking while searching, refining as it goes.
So it's not just blindly pulling links.
No, it's evaluating. Then it sends findings back. The lead researcher synthesizes these, decides if more digging is needed, maybe refines the plan, maybe spawns more subagents. Once it decides it has enough, the research loop finishes. All the findings get passed to a separate citation agent. This agent's whole job is to go through the generated report and the source documents and pinpoint exactly where the information came from for citations.
That's crucial for research, ensuring proper attribution.
Absolutely. Only after that rigorous citation process do the final results, properly cited, get back to you, the user.
Wow, okay. That's a pretty intricate dance between these different agents, which brings me to something you touched on earlier, guiding these agents. It sounds like prompt engineering here must be incredibly complex, right? It's not just asking a simple question anymore.
Oh, it's a huge part of making this work. And Anthropic shared some really valuable lessons they learned about prompting these agentic systems. The first big one, maybe counterintuitive, is you really need to think like your agents. They found that building simulations and just watching the agents try to work step by step was the fastest way to see where things broke down.
Like seeing them make weird search queries or pick the wrong tool.
Exactly. Things like overly verbose search queries or getting confused about which tool to use for what. Seeing it happen makes it obvious what needs fixing in the prompts. Then, building on that, you have to teach the orchestrator how to delegate effectively. The lead agent needs really clear instructions on how to break down the user's query and what to tell each subagent. We're talking clear objectives, specific output formats they need to return, guidance on tools, even setting boundaries so they don't overlap too much.
Right, otherwise you get chaos.
Totally. They give an example. Without clear delegation for a query about the semiconductor shortage, one subagent might go off researching the 2021 car chip crisis, while two others waste time both looking at the current 2025 supply chain. Duplicated effort, potential gaps. Clear delegation prevents that.
Makes sense, like managing any team project, really. You need clear roles and responsibilities. What else did they find crucial?
Another big one is scaling the effort to match the query's complexity. Agents need explicit guidelines on how much work is appropriate. A simple fact check might just need one agent making 3 to 10 tool calls. But really complex research might involve spawning more than 10 subagents, each with a clearly defined piece of the puzzle. The prompts need to guide that scaling.
Okay, so the system needs to judge how deep to go. And the tools themselves.
Critical. Tool design and selection are absolutely vital. They stress that the agent-tool interface is just as important as the human-computer interface. Agents need good heuristics. Rules of thumb like always check all available tools first or prefer specialized tools if they fit. And simple things like bad tool descriptions. They can send an agent completely off track. Clarity is key.
That's interesting. So the description you write for a tool isn't just for humans, it's for the AI agent using it.
Exactly. And here's something really cool. They found you can let the agents improve themselves. Claude 4 models, they said, can actually be excellent prompt engineers. They even built a specific tool testing agent. Its job was to try using a tool, and if it struggled, it would actually rewrite the tool's description to be clearer for future agents.
Wow, AI optimizing the instructions for other AIs.
Yeah. And they saw results. This led to a 40% decrease in task completion time for agents using those improved descriptions later on. A few other quick ones. Start wide, then narrow down. Just like human research. Prompt the agents to begin with broad queries, evaluate, then get more specific. Counteracts the AI tendency to sometimes jump to overly narrow searches too soon.
Good research practice, basically.
Right, and guide the thinking process. They use something called extended thinking mode, where Claude outputs its reasoning steps visibly. This acts like a scratch pad and improves how well it follows instructions, reasons, and works efficiently for both the lead and subagents. And finally, something we touched on. parallel tool calling is transformative, making the lead agent spin up multiple subagents in parallel and having those subagents use multiple tools in parallel that massively cut research time, up to 90% for complex queries.
So it's not just about writing good prompts, it's about architecting the collaboration and workflow efficiently, instilling good research heuristics within the AI system.
Precisely. It mirrors how skilled human teams approach complex research. But, building something this dynamic raises a really important question. How do you actually evaluate it effectively?
Yeah, that sounds tricky. Because if these systems are non-deterministic, meaning they might take different paths each time, how do you know if it's working well? Traditional tests often assume there's one right way to get the answer.
Exactly. You can't just check if it followed predetermined steps if multiple valid paths exist. Anthropic outlined their approach to effective evaluation of agents. First, they emphasize, start evaluating immediately, even with small samples. Don't wait. Especially early on, small changes can have huge impacts. They found even just 20 or so queries, if they represent real user scenarios, can show you if you're making progress, like seeing success rates jump from, say, 30% to 80%.
So rapid feedback cycles, even with limited data.
Right. Second, they found that LLM as judge evaluation scales really well when done right. For tasks that produce free-form text, having another powerful LLM evaluate the output against criteria like factual accuracy, citation accuracy, completeness, source quality, even tool efficiency. That works. It gives scores, pass-fail grades. They found it particularly useful when there is a reasonably clear right answer, like lifting companies with top R&D budgets. It lets you scale evaluation across hundreds of outputs much faster than humans could.
Okay, so AI judging AI for scalability. Makes sense. But are humans still needed in the evaluation loop?
Oh, absolutely crucial. Their third point is that human evaluation catches what automation misses. LLM judges are powerful, but humans are still better at finding those weird edge cases or subtle qualitative issues. For instance, they mentioned early on, human testers noticed agents kept picking these, SEO-optimized content farm websites over more authoritative sources like academic PDFs or even expert blogs just because the farms ranked higher.
Ah, the kind of nuance an algorithm might miss.
Exactly. That human feedback led them to add specific source quality heuristics into the agent's prompts. Automation didn't catch that. Humans did. You need both.
Okay, so evaluation is complex but doable with a mix of methods. Now, shifting gears slightly, what about just keeping these things running reliably, the production side? These sound way more complex than a standard web app.
They absolutely are. Anthropic dedicates a good chunk to the production reliability and engineering challenges, which are pretty unique for these agentic systems. A huge one is that agents are stateful and errors compound. Unlike a simple request response, these agents run for potentially long periods, holding state, making sequences of decisions based on tool outputs. A small error early on, maybe a tool fails, or the agent misinterprets something, can snowball and completely derail the whole research process later.
Right, the longer it runs, the more chances for something to go wrong.
Precisely. So they had to build robustness in. For example, systems designed to resume an agent's work from where it left off after an error, rather than just restarting the whole thing from scratch. They even built in logic to let the agent try to adapt if a tool temporarily fails.
That sounds essential. What about debugging when things do go wrong? If it's non-deterministic, how do you even find the root cause?
Yeah, debugging is another major hurdle. Because the decisions are dynamic, you can't always just replicate the exact scenario. They found that full production tracing is necessary. You need detailed logs of the agent's entire decision-making process. What prompts it used, what tools it called, what results it got, what decisions it made based on those results. This helps diagnose problems like why did it use a bad search query? Why did it trust a poor source? It involves carefully monitoring these patterns and interactions, while also being extremely careful about maintaining user privacy, of course.
A whole new level of observability needed. And deployment. Getting new versions out must be tricky too.
Definitely. Agent systems are described as these highly stateful webs of prompts, tools, and execution logic. You can't just flip a switch to a new version without potentially disrupting agents that are currently mid-research. They use a technique called rainbow deployments. It's a way to gradually shift traffic over to a new version. You run the old and new versions side by side for a while, slowly moving users over, which lets you catch issues with the new version before it impacts everyone and without interrupting those long-running agent processes.
Okay, that makes sense. It sounds like there's also a bottleneck in how things run currently. Something about synchronous execution.
Yeah, they mentioned that currently, the lead agent often has to wait for sub-agents to finish their tasks before it can proceed. This simplifies the coordination. It knows exactly when results are ready, but it does limit the potential for even more parallelism. They point to asynchronous execution, where agents could work more independently and signal completion as a future enhancement. It promises more speed and parallelism, but adds significant complexity in coordinating everything.
So we've covered the concept, the architecture, the prompting, evaluation, the engineering. Bringing it all together, what does this mean for you, the listener? What's the actual tangible impact these systems are having?
Well, despite all those challenges we just discussed, the clear message from Anthropic is that these multi-agent systems are already proving incredibly valuable, especially for those messy, open-ended research tasks. They shared anecdotes from users who've used the research feature to find business opportunities they hadn't considered or navigate really complex healthcare options. Others used it to resolve thorny technical bugs or even save up to days of work by uncovering research connections they wouldn't have found on their own.
So real productivity gains and insights people weren't getting before.
Exactly. And they backed this up with data showing the top use cases, visualized in this thing called a Clio embedding plot. It showed clusters around things like developing software systems. There was about 10% of usage. Optimizing professional or technical content was 8%. Developing business growth strategies, another 8%. Assisting academic research, 7%. And just general research or verifying info about people, places, organizations, about 5%.
So it's being applied across a pretty wide range of professional and knowledge work tasks.
Definitely. It's not just a theoretical toy. It's delivering practical value for complex information work.
And I think they included a few extra quick tips in an appendix too, right? For people potentially building similar systems.
Yeah, a couple of interesting ones, like end-state evaluation. For agents that change things over many steps, focus on evaluating the final outcome, not necessarily every single intermediate step. Also, long-horizon conversation management techniques for summarizing completed phases of research and storing key info externally so agents can maintain context over very long tasks without getting bogged down. And letting subagents write outputs directly to a file system or external storage, bypassing the main coordinator sometimes to save on tokens and prevent information loss. Little tricks for efficiency and robustness.
This has been a fascinating deep dive. It really shows the combination of, well, advanced AI thinking and some really meticulous, clever engineering needed to make these collaborative AI systems work in practice. It's clearly way beyond just having a single powerful language model. It's about orchestrating an entire team.
It really is. And maybe a final thought this leaves us with. As these AI systems get better and better at thinking and working like a coordinated team, leveraging that kind of collective intelligence, it raises a really important question for all of us, doesn't it? How might that fundamentally change the way we approach our own research, our own problem solving, maybe even innovation itself in the years to come?
That is a fascinating thought to ponder. Well, we hope you've enjoyed this exploration into the world of multi-agent AI research systems. Hit like and subscribe if you like the content. See you next time.